Hey, physics fanatics and comedy connoisseurs. Ever wondered what happens when a super speedy ladder tries to sneak into a tiny barn? Get ready to have your mind bent and your funny bone tickled, because today we're diving into the hilarious and mind-boggling world of the ladder paradox. So what exactly is this paradox? Imagine a ladder, let's say 10 meters long, and a barn, let's say 8 meters long. Simple, right? But here's the twist. What if that ladder is zooming towards the barn at nearly the speed of light? Does it fit? Our scene is set. A charming barn, a perfectly normal ladder, and a runner who's clearly had too much coffee. He's about to push this ladder into the barn at warp speed. The big question that has perplexed physicists and probably a few confused farmers for decades. If the ladder is moving fast enough, does it really shrink enough to fit inside the barn, even just for a split second? Now, if you're thinking, this is absurd, a 10-meter ladder can't fit into an 8-meter barn, then congratulations, you're thinking classically. In our everyday low-speed world, that ladder is just too darn long. Without any fancy physics, a 10-meter ladder is always 10 meters long, and an 8-meter barn is always 8 meters long. No amount of pushing, wishing, or even a really strong coffee will make that ladder shrink. So from a normal, non-relativistic perspective, the answer is a resounding nope. It's like trying to put an elephant into a shoebox. Not gonna happen unless that elephant is made of spaghetti. But then, out of the relativistic ether, came a man with wild hair and even wilder ideas. Dramatic sound effect. Whoosh! It's Albert Einstein, here to mess with our common sense and introduce us to special relativity. Einstein's theory of special relativity tells us some mind-blowing things about space and time, especially when things start moving at speeds close to the speed of light. Forget what you think you know, because things are about to get weird. One of the coolest concepts is length contraction. Basically, the faster an object moves relative to an observer, the shorter it appears to be mean in the direction of its motion. It's like the universe puts a squish filter on speedy things. Now let's put on the ladder's sunglasses and see things from sight's perspective. If the ladder is moving, it feels perfectly normal to itself. But what about the barn? From the ladder's point of view, it's not the ladder that's moving. It's the barn that's rushing towards it at incredibly high speed. And because of length contraction, the barn will appear shorter to the ladder. So, to the ladder, the 8-meter barn, now appearing even shorter, is perfectly capable of holding the 10-meter ladder. Ha! Take that, barn, says the ladder, smugly fitting inside. This is where the cartoon logic really kicks in. Alright, let's swap sides. Now we're chilling inside the barn, sipping lemonade, watching this crazy ladder hurl itself our way. From our Stoics' perspective in the barn, what do we see? From the barn's perspective, we are stationary, and the ladder is moving at an insane speed. Therefore, according to length contraction, the 10-meter ladder appears to us in the barn as significantly shorter. So, to the barn, the 10-meter ladder, now appearing much shorter, easily fits inside the 8-meter barn. Phew, that was a close one. Almost needed a bigger barn, says the barn, relieved. The irony is palpable. So the ladder thinks it fits, and the barn thinks it fits. Is everyone just seeing things? Has special relativity driven us all mad? No, dear viewers. This is where the magic of simultaneity comes in. The key to resolving this mindbender is understanding that at the same time isn't universal. What appears simultaneous in one frame of reference might not be in another. The front of the ladder might be in the barn before the back has even entered from the ladder's view, while the barn sees the whole ladder enter simultaneously. Both perspectives are correct, because they are observing events from different frames of reference. It's like saying a spoon is both curved and straight, depending on whether it's in water or air. Physics, ain't she a trip? So the ladder paradox isn't a contradiction, but a fantastic illustration of how our everyday intuition breaks down at relativistic speeds. It shows the bizarre yet beautiful consequences of Einstein's theories. It's a truly hilarious concept once you wrap your head around it. A ladder that's too long, yet perfectly fits, all thanks to a little bit of speed and a whole lot of relativity. Who knew physics could be so comically confusing? What are your thoughts on this paradox? Let me know in the comments. Don't be a paradox. Share the knowledge. Like, share, and subscribe for more videos that will mess with your head in the best way possible. And don't forget, from beyond